Factoring ax squared plus bx plus c, which means we have a leading number in front of the x squared that is not 1. So let's just say for this, its a will not equal 1. So let's take a quick example. What would that look like, an ax squared? So let's say we had 2x minus 3 times x plus 5. Now we get, okay, so if we FOIL this out, and I'm going to do all four, although I rarely do that when I'm working. So 2x times x is, I'm just going to move my mouse, 2x squared. That's first, outer plus 10x. Inner minus 3x. And last, minus 15. Now, normally if I multiply that out, I just do it in my head and I go 2x squared. Plus 10x minus 3x will be plus 7x. And then minus 15. Okay, so where does the 2x squared come from? This first product is only from the two first factors in our binomials. Where does the negative 15 come from? Only the last terms in our binomials. That gives us the minus 15. And where do we get 7x? That's a combination of the outer product, 10x, and the inner product, minus 3x. So when we are factoring trinomials of this form, let's keep that in mind. Okay, so let's start off. Okay, I've tried getting rid of this and I can't. We're actually going to leave this one for a moment. We'll come back to it in a sec. Let's do something similar. Let's go 3x squared minus 14x minus 5. Okay, so how do I get 3x squared? Only one way. 3x leading one binomial, x on the other, because this first term only comes from the product of the first terms of each binomial. How do I get a 5? Again, there's only one way to get a 5, and that is 1 times 5. But the question is, which one is the 1? Which one is the 5? What are the signs? So we know that we have, since we have the negative 5 only comes out of a 1 and a 5, and one of them is positive, one of them is negative. So let's take a look. I need a minus 14x. So if I put the 5 here, and the 1 here, ignoring the signs for a moment, I'll get 3x squared, and then a 3x and a 5x. Well, 3x and 5x can only combine to give me either 8x or 2, give me an 8 or a 2. Adding them together or subtracting one from the other gives me 8 or 2. So that's not where the 1 and the 5 go. So let's clear those out. That's why we use pencil or equivalent. Okay, you don't want to do math in pen. Never pen, always pencil. Have a good eraser handy. Okay, so where were we? There's a 5 here and a 1 here. This will give me 3x squared. This will give me a 15x, and this will give me a 1x. I need those to combine to give me minus 14. So let's put a minus there and a plus here. We know these are opposite signs, right? We know that's plus 1 minus 5 or minus 1 plus 5. So FOIL it out now. 3x squared minus 15x plus 1x gives me minus 14x minus 5. This method is called guess and check. And so the important part is check. Once you've guessed, right, once you've filled this in, then you have to check and make sure that these signs are in fact correct. If you had put a plus here, you'd get plus 15x. The minus here would give you a minus 1x. You'd end up with a plus 14x. Okay, so that would be the wrong way around. Okay, moving up here, this is a little more difficult. Since the 5 here could only be 1 times 5, but the 6 can be 1 times 6 or 2 times 3. So what are we looking at? Well, I have a minus here. That means these are opposite signs. So my possibilities are I could have a plus 1 with a minus 6. I could have a minus 1 with a plus 6. I could have a minus 2 with a plus 3. And I could have a minus 3 with a plus 2. Right? That's the only way to get a 6 is 1 times 6 and 2 times 3. They are opposite signs, so we have to evaluate all of these. Well, if I take the 3x and multiply it by a negative 6, that's going to give me minus 18, and then I'll get a 1x. Well, a product of 18 and 1 is not going to do it. So it can't be a 1 here and a 6 here. Well, what if the 6 were here and the 1 were over here? Well, then I would get 3x squared, that's my leading term, we know that. I would have a plus or minus 3x with a plus or minus 6. Can I combine a 3 and a 6 to get a 7? No. If I add 3 and 6, I'll get 9, and if I subtract 3 and 6, then I will get, subtract 3 and 6, I will get 3. That won't give me the 7. Okay, so we know that it's not a 1 and a 6 in any particular form here. Right, and what else could we do? I guess over here we could have a plus 2 and a plus 3, and then with that would go minus 3 and a minus 2. So let's take a look. 3x squared. Now if I multiply by 3, I'm going to get a 9 here, and then if I multiply these by 2, because if there's a 3 over here, then there's a 2 over here, then I'm going to get a 2. Well, can I combine 9 and 2 to get 7? Sure I can. So let's clean this up a bit, because we know now that I'm picking up my canvas and moving it. So we now know, clean. Okay, move canvas. We now know that we need a 3 here. Oops, got to go back to a pen. So a 3 here. There, move canvas, and a 2 here. So 3x squared, 9x and 2x. Well, I'm going to need a minus 9x and a plus, oops, I already said 2. So what do we got? 3x squared minus 9x plus 2x gives me minus 7x, and then these two, which must have opposite signs, must be plus 2 minus 3, giving me minus 6. Guess, yes, check, yes. So what are we looking for? Okay, taking a look at this one, we're looking for two numbers that multiply to 5. That's easy because it's a 1 and a 5, right? So there's a 1 here and a 5 there, or vice versa. Here we have a 6. We need to look at the factors of 6, 1 and 6, 2 and 3, and try and combine them. Now I don't worry about all of the signs. I'll worry about that a bit later. I do know that there's one positive, one negative, and here again also one positive, one negative. So let's try something where we have a positive last term. Let's do a couple more of these. We'll do it with a positive last term, a positive middle term. Let's start with that in just a moment. Okay, two examples here. 5x squared plus 36x plus 7, and 5x squared minus 8x plus 7. Okay, so this has to go with a 5x and an x. Since this is positive, we know both terms are positive, or both terms are the same sign, and this tells us they're both positive. So we got a plus and a plus. And we have to fill in the numbers. Well, the only numbers that work here are 7. So either the 7 is here and the 1 is here. 7 and a 1. That will give me 5x squared plus 5x plus 7x. Well, that's 12, so that's not it. So that means that the 1 must be here and the 7 must be here. Okay, that's the guess. Let's check. 5x squared plus 35x plus 1x is plus 36x plus 7. Bingo. And 5x and x in this one. This is a plus. They're both the same sign. Since that's a minus, they must both be minus. Okay, two numbers that multiply to 7. Well, if I put the 7 here as we did above, we will get minus 35x. And then the 1 will be here. We'll have a minus 1x. Well, that will give me minus 36x, which would be this one if that were a minus. But it's not. So the 1 goes here. The 7 goes here. 5x squared minus 5x minus 7x plus 7, that's minus 12x, and I have a minus 8x. So what I wrote here won't actually factor. How embarrassing. Let's change this to a 12. Again, we knew that there had to be a 1 and a 7 here. Okay, so 5x squared minus 5x minus 7x is minus 12x plus 7, right? What are the only possibilities when the two signs are the same, right? You could have the 1 here and the 7 here. As we did here, that would give me a 35x and a 1x. If they're both the same sign, then it's plus 36x or minus 36x. And here, with the 1 and the 7 reversed, if they were both plus, I would have a plus 5x minus, or plus 7x, which would give me a plus 12x or minus. So it can only be plus or minus 12x when this is a positive 7. Okay. What if we had, and this isn't exactly factoring, but what if we had a plus 7? Sorry, a minus 7 here. Then let's look at minus 7. So let's say we had a plus 1 and an x minus 7. Okay, that would be 5x squared minus 35 plus 1. Right, so the two numbers we're dealing with are 5 times 1 and 7 times 1, if I put a 1 here, or 5 times 7 when the 7 is here, and a 1 times 1. If it's 5 times 7, that's a 35 and a 1. So either we are dealing with a middle term that's a 36 or a 34, right? Plus or minus. They either add to 36 if they're both the same sign, right? And this could be a minus, or they differ by 35 and 1, differ by 34, which would be, again, plus or minus depending on the signs that we put here. So that's what you're looking for. Now, let's do some where we do not have nice prime numbers here and here. Okay, something more along these lines where this was a non-prime number, right? So it could have been a 1 and a 6, or it could have been a 2 and a 3. How will we deal with that? Okay, 6x squared plus 13x minus 5. Part difficult, as in how do we get 6x squared? We're either leading with a 6x and then we have an x in the other bracket, or it's a 3x and a 2x. This one's easy because the only way to get 5 is 1 and 5. So let me put my brackets down. I don't know what goes in here, right? It's either 6x and 1x, or it's 3x and 2x. So I'm going to go over here and say, okay, either it's a 1 and a 6, or it's a 2 and a 3, and that's what leads here. At the end, I must have a 1 and a 5. So let's try and combine 1 and 6 with 1 and 5 and see if we can get a 13. So 6 times 5 would give me 30, and 1 times 1 would give me 1. Well, I can either add those to get 31, or they differ by 29, so I cannot get a 13. How about 6 times 1 and 1 times 5? That gives me a 6 and a 5. 6 and 5 combine, add to give 11, or they differ by 1. No way to get a 13. So let's examine 2 and 3 and 1 and 5. So 3 times 1 is 3, and 2 times 5 is 10. Now 3 and 10 can give me a 13, but they have to add to 13, which means that they're both the same sign, and in this case we know they're not both the same sign, right? We have one positive, one negative, so that's not a way to get to 13. They add to 13, or they differ by 7. So this would have to be a 7, a plus or minus 7 to go that way. So 3 times 5 is 15, 2 times 1 is 2. 15 and 2 differ by 13, right? And we know from what we did the other day, we know that when there's a minus here, the two numbers must differ by. Okay, so the 3 has to multiply the 5. So I'm going to start off with a 3x here, and the 3 multiplies a 5, and a 2x here, and then what goes with the 5 is a 1. Now I need my signs, right? This will give me 6x squared. This will give me 15x. That needs to be big, a big positive 15x. So that's a plus. And then here we have the minus. Okay, that's my guess. Let's check. 3x times 2x is 6x squared. Plus 15x minus 2x will be plus 13x and minus 5. Okay, good. We've checked it. One thing about factoring is you can always check. And the important other thing about factoring is make sure there's no common factor inside the brackets. That's a 2x, and if it's a 2 and a 5, no common factor. A 3 and a 1, again, no common factor. All right, let's step it up a bit. what if, since this was a 5, we knew that it could only be 1 and 5? Well, let's do another example where we get a number on the end here, which, let's say we have a 4 on the end. And with a 4 on the end, so let me just move this down a bit. With a 4, we know that 4 is 1 times 4, or 2 times 2. Okay, so let's close that off. 6x squared. So we'll still lead off with the 6x squared plus 10x minus 4 equals 2 sets of brackets. Now, since this method is guess and check, you're not really necessarily required to show any work here, right? Okay, so how do I get a 6? I do a 1 and a 6. How do I get a 4? Well, I can do a 1 and a 4, or a 2 and a 3. Well, how else can I get a 6? Well, I can also get a 6 by 2 and 3. And that could be paired up with either 1 and 4. Oops, did I say 2 and 3? That's 2 and 2. Or 2 and 2. So, looking at these, 6 times 4, 24 and 1. Can't get a 10. 24 and 1 gives me 25 or 23. Okay, how about 6 and 1? 6 and 1 does give me 10, but I have to add 6 times 1 is 6, 1 times 4 is 4. 6 and 4 gives me a 10, but I have to add them, and here we know they have to differ by 10. Okay, what else can I do? 6 times 2 is 12, and 1 times 2 is 2. So that 12 and 2 I can differ by 10. Okay, so I can do a 6x and an x here. That'll give me 6x squared. I want a plus 10x, so I'm going to go plus 2, and over here minus 2, giving me 6x squared. Plus 12x minus 2x is plus 10x minus 4, right? Minus 4. But, wait, you say, hang on, they're both divisible by 2. I can take a 2 out of this factor. This will be 3x minus 1 and x plus 2. So, that was bad, you say. You should have recognized that in the original, that this was all divisible by 2, and I should have started by, let's go up here, should have started by factoring the 2 out of there, giving me 3x squared plus 5x minus 2. Cannot draw the 2. I'm on the edge of the tablet. Here we go. Minus 2, right, which is equal to 2. Now everything's nice and prime. That's a 3x and an x. I need a 5, so I'm going to go plus 2 there to give me plus 6x, minus 1 to give me the minus 1x, and minus 2. So it's the lesson, common factor first. Okay, let's do one more, and then we'll turn you loose for your homework. Okay, 12x squared minus 29x plus 15. So where does the 12x squared come from? Well, either a 12x with a 1x, a 6x with a 2x, or a 3x with a 4x. Right? So we have a lot of possibilities for the leading terms. And 15, 1 and 15, or 5 and 3, right? Or other way around, but there's a 1 and a 15 and a 5 and a 3. And they need to combine to give me a minus 29. In this case, since this is positive, they add to, right? They add up to. So let's take 1 and 12, and let's try that with, I'm just going to go this side here. Let's try that with 1 and 15. 12 times 15 is really big, and this is a 1, and really big and a 1 won't get you a 29. Okay, how about the other way? 12 and 15. 12 and 15 will get you a 27, not the 29. Okay, how about 3 and 5? 12 times 5 is 60, 1 times 3 is 3, that gives me 63. 12 times 3 is 36, 1 times 5 is 5, that gives me a 41, neither of which are 29. So we do not have a leading 1 and 12. We don't know for sure if this factors, right? But if it does, this is the methodology we're going to go through. Okay, so 1 and 12 are out. So that gives us, what's next? 2 and 6. Okay, let's try that with 1 and 15. 6 times 15 is big. Big plus 2 is way bigger than 29. 6 times 1 is 6, and 2 times 15 is 30. That's 36, not 29. Okay, how about 3 and 5? We got 30 and 6. Nope. We have 18 and 10. Close. No cigar. So that's out. Okay, how about 3 and 4 with 1 and 15? So 4, that's 60 and 3, which is 63. This is 4 and 45, which is 49. Nope. 3 and 5. This is 20 and 3. 20 and 3 is 29. So we have leading terms of 3x and 4x. The 3 multiplies a 3, so that goes here. And the 4 multiplies a 5, so that goes here. I got a plus 15, so they're both the same sign. And what sign are they? This sign. They are both minus. Minus, minus. That's the guess. Let's check. 12x squared minus 9x minus 20x is minus 29x plus 15. Okay, there we go. That's it. That's the total amount of work that we need to show. In guess and check, we really aren't showing work. This pretty much can be done in your head, okay? And you'll get a feel for it the more of these that you do. That generally speaking, it's not a 1 and a 12, right? So you start with 2 and 6, and the 15, that's just too big, right? Because that's going to give me, you know, no matter what, with a 15 and the 1 and the 2 and the 6, that's going to give me a 30, or a whatever 6 times 15 is, a 90. I'm not getting a 29 out of that. So if I'm thinking 2 and 6, I'm thinking to combine them with 5 and 3. Okay, and again, you just you can work through that stuff in your head. You can also put some work down here, or keep a scratch piece of paper on which to, you know, list your possible factors. There are other methods of factoring this. You can find probably thousands of them on YouTube. This is the only one I'm going to show you, guess and check. You know, it takes a little bit of work. It's a little bit of getting used to the numbers, working with the numbers, and that. So practice will in fact make, if not perfect, then certainly much better. And that's it for this particular lesson.